Alright, now let's finish off this segment on simple regression by talking about the sum of squares notation. At first this will look not useful, doing too much notation. In the long run you'll see that some of these items we use in terms of sum of squares we use over and over again, and it's easier to do once instead of several times. Alright, let's go back and talk about concepts in 214 when we talked about a sample variance. Let's call it S squared. Well, let's right now just call it variance of x. The formula for that is sigma x squared minus n times x bar squared divided by n minus 1. Alright, back then we didn't understand all of that, and we still don't, but right now we probably better understand that the n minus 1 is actually the degrees of freedom. Top line, the numerator here, is called the sum of squares. It's the notation that we'll use is s sub xx for the sum of squares of x, and we'll divide that by the degrees of freedom. Alright, so just to be clear about that, the sum of squares of x is sigma x squared minus n times x bar squared. The value must be positive, could be equal to 0, but then the variance of x would be equal to 0. Okay, so this is sum of squares of x. Down the way we'll also need a similar item for the variable y. So the sum of squares of y will be, and just replace all the x's up here with y's, sigma y squared minus n times y bar squared. This also must be positive. Alright, let's call the sum of squares of y. And it also could be used in the calculation of variance. For instance, the variance of y will be the sum of squares of y divided by its degrees of freedom, n minus 1. Okay, there's another similar related item to these two, and that's called covariance. Covariance between, say, two variables, x and y, which we'll, instead of writing the whole thing, like we didn't say variance of y, just var, now it's COV x comma y. Alright, this will also be a sum of squares. Sum of squares divided by the n minus 1 degrees of freedom. Alright, so s of xy is the sum of squares of xy. Alright, and the formula for it. Alright, look at both the sum of squares of x and the sum of squares of y. In each of them there are two x's, two y's. Replace one of those two with the other. So it'll be sigma xy minus n times x bar y bar, and this is sum of squares of xy. It does not have to be positive, so it could be positive or negative. Alright, and we've already seen this term before. We've used it in the beta head 1 calculation, just like we've used the sum of squares of x in the beta head 1 calculation. Okay, so right now let's rewrite the formula for beta head 1, and we'll use that formula from here on out. So beta hat 1 is the sum of squares of xy divided by the sum of squares of x. Beta hat 0 is the same as before, y bar minus beta hat 1 times x bar. Okay, these are the formulas that will be used in the first Excel homework. Instead of the first formula for beta hat 1, we'll use the sum of squares formula.